Hi guys, welcome to our next video for Flipped Classroom. Today we're going to be working through pages 9 to 11 in your booklets. The learning objectives for today are being able to understand what a salt is and how it relates to acid reactions, understanding a range of different reactions involving acids, and some applications of neutralization reactions in different industries. We're going to start off with what a salt is. Usually, when we think of a salt, we think of normal table salt or sodium chloride, which of course is a salt, but in chemistry, we define a salt as any compound that is formed when a metal takes the place of a hydrogen atom in an acid. We're going to have a look at a few examples. This slide shows a few examples of what salts would be formed by the following acids. Notice at the end of the acid name, such as chloric, the salt name ends in chloride, which are the negative ions associated with the acid. So, for hydrochloric acid, which contains one hydrogen atom and one chloride atom, a few salts we could generate are sodium chloride and potassium chloride. The chloride ions are not swapped out, it's only the hydrogen atoms that are. Looking at the next example, hydrobromic acid contains one hydrogen atom and one bromide atom. The hydrogen is again swapped, but the bromide ion remains in the salt generated, such as calcium bromide or sodium bromide. As you look down the table, you can see this trend is illustrated again and again. So when acids are mixed with active metals, which are usually metals from group 1 or 2 of the periodic table, we see that as products we form a salt and hydrogen gas. For example, if we were to add hydrochloric acid to magnesium metal, we would get as our products magnesium chloride, the salt, and hydrogen gas. What would we get if we had hydrochloric acid and sodium? Pause the video and have a guess. If you said sodium chloride and hydrogen gas, you'd be correct. We would get normal table salt and hydrogen gas as our products if we were to add hydrochloric acid and sodium together. Acids can also react with bases, and when they do so, these are called neutralization reactions. Bases can contain hydroxides, oxides, carbonates, or hydrogen carbonates and bicarbonates. The reason for calling these types of reactions neutralization reactions is that the acid and base cancel each other out. When we have acids and bases that contain hydroxide ions, we form a salt and water. For example, if we have sulfuric acid, which contains sulfate ions, and potassium hydroxide, we find that the salt is sodium sulfate, and also form water. Similarly, with nitric acid and sodium oxide, we form the salt sodium nitrate and water. When the base that we're adding to the acid contains carbonates or hydrogen carbonates, we also get a salt and water, but with the addition of the carbon atoms in the carbonate, we also make carbon dioxide gas as well. Just going to go through one of the examples here. If we have hydrochloric acid and add calcium carbonate to the mix, we'll get calcium chloride as our salt. Remember, the metal of the base replaces the hydrogen of the acid, water, and carbon dioxide gas. Here's just another example. In the next few slides, we're going to be looking at some applications for these neutralization reactions. In your booklets, you need to add 2 of these gardening applications and 2 from the health applications in the next slides. So the neutralization reactions are actually pretty important for gardening, as plants need a specific pH range within the soil. Usually it's stated on the back of the tag that the plant comes with. There are also pH kits that you can use at home to test the pH of your soil. If the soil is too low or too acidic, it can be increased by adding some lime or calcium carbonate. If, on the other hand, it's too basic and we need to reduce the pH of the soil, you can add sodium sulfate. Some health applications include toothpaste being slightly basic to counteract the acid on your enamel of your teeth. The acid comes from bacterial waste, which aid in the breakdown of food, especially when it gets stuck in your teeth. If we don't brush our teeth, we get cavities because the acid from the bacteria slowly dissolves the tooth enamel, and then we need to go to the dentist to get a filling. Another example is antacid tablets. These help neutralize the acidity of the stomach, which is caused by indigestion, where there is an over acid in our stomachs. We can also add chlorine to swimming pools to protect us from bacteria and algae that are likely to grow in it. By adding the chlorine, we make a weak acid. If we add too much chlorine and the pH becomes too acidic, we can balance this out by adding a base of either sodium carbonate or sodium bicarbonate to increase the pH and stop the irritation of our skin and eyes. Finally, we use acids and bases all the time in the food industry. We use vinegar to pickle foods and prevent the formation of microorganisms living on our foods. We use sodium bicarbonate, a base, when we are baking, as it reacts with the weak acid in the cake mix to produce carbon dioxide gas, which is what the cake mixture causes it to rise. There is another space in your booklet for another example. This is for you to research. This is the end of the video. Again, we'll be starting the next class with another pop quiz, so please make sure you reread your notes for this section.